Hey guys, I just want to say thank you so much for visiting the channel today. Today we have a great lab for you. We're going to be configuring some BGP with network address translation. We're going to do a demonstration of static network address translation, and we're also going to do port address translation. We're going to check out some packets in Wireshark, and it's going to be a great time. So let's dive right in. All right, what's up guys? Here we are in our topology. So explaining a little bit about our topology, we do have a NAT interface here that's going to give our lab internet connection through VMware. We have 4 routers here. We got 2 as edge routers and 2 as ISP routers simulating an ISP environment. We got a couple of different autonomous systems to simulate a BGP network. First thing we're going to do is to configure loopback interfaces on all of these routers. I've already went ahead and opened up the actual physical interfaces and configured those with IP addresses. And so the only thing that we're going to do is configure the loopback interfaces. Now, the reason we're doing that is we're going to use the loopback interfaces in order for our BGP connections because it makes the connections a lot more resilient. So whenever you form a neighborship with, for instance, if you were configuring BGP on ISP router 2 and you're configuring the BGP neighbor relationship, and so you configure edge router 1 as a neighbor by its G00 physical interface. What will happen is if that interface goes down or loses connectivity for any reason, then that neighborship is lost. So we want to configure some loopback addresses to make that connection more resilient. Now, another reason, especially in this lab, what makes it so important is that whenever you are configuring NAT can sometimes break that BGP neighborship by natting the BGP packets that come in. And so whenever those BGP packets come in, NAT is performing on those BGP packets and it breaks that neighbor relationship. We can configure the source of the BGP packets from a loopback interface to a neighbor loopback interface. And so the thing is that especially in a real life scenario, when you have multiple different connections to a neighbor router. So just pretend that you can get to edge router 1 via this link here, or maybe just say that there was a link from ISP router 1 to edge router 1. If there was a link from ISP router 1 to edge router 1 and this link goes down, if I have ISP router 2's BGP neighbor configured as G00, that breaks the relationship. But if I have ISP router 2's neighbor configured as edge router 1's loopback interface, then it can still maintain that neighborship via the other connection via ISP router 1. And so that loopback interface gives our connections more resiliency. These physical interfaces go down all the time. They can go down for any reason, but that loopback interface is not going to go down unless the entire router itself goes down. And so that's just a little bit about why we do that. And a little bit we're going to do this lab. Like I said, we're going to configure those loopback interfaces on the routers for the BGP neighborships. Then we're going to we have to configure the static routes in order for those the routers to know how to get to those loopback interfaces. We're going to configure BGP on all the routers, and then we're going to configure a static NAT demonstration using edge router 1. And then we're going to actually configure the real NAT, which is the NAT that we use mostly, which is port address translation, which allows many different internal network devices to be mapped to one public IP address. And we're going to use our client devices down here to test the network connections, and then we're going to look at those packets via Wireshark on ISP router 1's interface as they come into ISP router 1. So let's just get started here on ISP router 1. We should be ready to go here. And so the first thing we'll do, let's say conft and interface loopback 0. And for these loopback interfaces, we're going to have to come up with an addressing scheme that kind of makes a little bit of sense. What I want to do is just kind of utilize this a little bit. So since ISP router 1 is its G00 interface in this network is 10.0.15.1, I'm just going to configure this loopback IP address as IP address 10.0.15. and then we'll say 10. 255.255.25. Okay, since ISP router 2 is 10.0.15.2, we will configure 10.0.15.20 on its loopback address. And for edge router 1, we will configure it to be 10.0.5.20 since it's going to be 5.2, and then 10.2 it will be 10.20. And so we'll just use that addressing scheme for our loopback interfaces. All right, so we are going to say enter on that. No, shut. I think it's already up, but do show IP interface brief. All right, our loopback on this one is up. So we got that done on ISP router 1. All right, we're going to move on to ISP router 2. Enable. So interface loopback 0. And like I said, this is going to be IP address. Let me look at the topology again, make sure it's 10.0.15.20. Okay. All right, we're good there. Moving on to edge router 1. Okay, IP address is going to be 10.0.5.20. Okay, good there. And finally, edge router 2. Okay. All right, we are good there. I just wanted to make sure I did the right mask on that one. It was kind of felt like I'd messed that one up for some reason. But all right, we have all the loopback interfaces configured. Now we're going to configure the static routes so that they can find each other's loopback interfaces. All right. So here, I'm going to exit interface configuration mode. We're going to say IP route, and we're going to route to ISP router 2's loopback interface. So that's going to be 10.0.15.20. 255. And that next hop will be 10.0.15.1. Invalid next. Oh, that's, I'm sorry, .2. There we go. All right. So do show IP route. Okay. Where is it? Oh, there it is. So we got that right there. We got, let's say do ping. All right, we can reach it. Next, ISP router 2. ISP router 2 is going to do most of the work in this topology. It's got the most connection. It's going to have the most BGP networks to advertise. And so here we're just going to say IP route. First, we're going to do ISP router 1, 10.0.15.10. And next hop is going to be 1. Okay. Oops. I'm getting off of that like I'm done. We have a couple more routes to do. So IP route, we're going to do edge router 1s, which is 10.0.5.20. That next hop is going to be 10.0.5.2. And then we're going to do IP route. Next hop, 10.0.10.2. Okay, now we are done with the static routes on ISP router 2. Let's get over to edge router 1. And edge router 1, exit interface configuration mode, IP route 10.0.15.20. Next hop is 10.0.5.1. And finally, edge router 2. So we're going to do 10.0.15. Oops, IP route. IP route 10.0.15.20. Next hop is 10.0.10.1 to show IP route. Okay, we can get to 10.20. Ping. Ping. Okay, all right, we can get there. So that should be all the static routes we need for this lab. Next, we're going to get busy with our BGP configuration on all our routers. So starting off again on ISP router 1, we are going to configure router BGP autonomous system 65015. And we're going to have a neighbor relationship with 10.0.15.20 and a remote system 65005. Okay. Also with the neighbor, we're going to 10.0.15.20, we're going to say eBGP Multihop. So we have to say eBGP Multihop since we're using the loopback address, because if you think about it logically, it does have to take 2 hops. It's got to take 1 hop to the G02 physical interface, and then to that logical interface, that loopback address, or that loopback interface. And so the only time you have to do that is when you're going from one autonomous system to the other. If you're configuring routers within the same autonomous system, you do not have to do eBGP multi-hop. And so we also want to send our BGP information from our loopback address as well. So we're going to say 20 update source loopback 0. Okay, so that's all of the configurations that we should need to do on ISP router 1 so far. We don't need to configure. I think I've already redistributed the, you know what? I probably haven't. Let's see. You know what? We'll go ahead and do it. So we're going to, let me explain this real quick. Show IP route. Okay, so we have the static route here. Now this static route is telling our entire network how to get out to the actual internet. Now we're going to need this in order to do our final test whenever we're testing our full network connection with our VPCs. So we also need to, we don't want to configure this static route manually on each and every device. And so we're going to propagate it throughout our BGP network. So in order to do that, we're going to have to redistribute it. And then we're going to have to tell it to give it the default information originate command in order for it to propagate that static default route throughout this BGP network. And so just back into BGP configuration mode, 65015. So here we're just going to say redistribute static IP. And so if we had a whole bunch of other static IP addresses, we would set up a route map and to tell it the only addresses that we want it to redistribute throughout the BGP network. But since we only have that one static route, that will do for this lab. And we're just going to say default information originate. And so that's going to pass that static default route throughout all of our BGP network. Okay, so now we are done on ISP router 1 for now. Let's get back to ISP router 2. Let's go ahead and configure this first neighborship. I'm going to say router, BGP, give me 65005. And we are going to say neighbor 10.0.15.10 on remote autonomous system 65015. Okay, and we're also going to want to say neighbor 10.0.15.10 eBGP Multihop 2, and also so that neighbor relationship just formed. Neighbor update source. Oops, update source loopback 0. Okay, so that is going to do it for our neighbor relationship with autonomous system 65015. Now we're going to have another neighbor relationship, neighborship with 10.0.5.20 on remote autonomous system. It's on the same one. We're also going to say neighbor 10.0.5.20 update source loopback 0. Now we are on the same autonomous system with Edge Router 1 and ISP Router 2, so we do not have to do the eBGP multi-hop, and that's going to take care of that neighborship. And so neighbor, we want to form a neighbor adjacency with Edge Router 2. That's going to be 10.0.10.20, and that's on remote autonomous system 65010. And here we are going to have to say eBGP multi-hop. And we're going to have to say update source. So that should do it for our BGP configurations for ISP router 2. Now let's just move right along to Edge router 1. On Edge router 1, I'm going to say router BGP autonomous system 65005, and I want to establish that neighbor relationship or neighbor adjacency with 10.0.15.20 on 65005. And we want to say neighbor did it again. Loopback 0. All right. So I'm curious on why I haven't seen the neighborship form yet. Let's see. Show IP route. And we misconfigured that static route. That's what happened. So we're just going to say IP route, or I'm going to say, first we're going to say no IP route. You can just say this to clear out all the static routes. So show IP route. Okay, we don't have that static route anymore. Let's say IP route, set the actual 10.0.15.20. And next hop is 10.0.5.1. Okay, that should do it. And do show. Okay, there we go. I was going to check it, but I think we are good to go there. So do show IP BGP summary. All right, and now let's move on over to Edge router 2. So router BGP, this is autonomous system 65010. And we're going to have an adjacency with neighbor 10.0.15.20 on remote autonomous system 65005. Okay, and we're going to have to do the eBGP Multihop, and we're also going to have to say, here, let's update source. All right, show IPVG. All right, we have that neighborship too. So we have an adjacency there. All right, it looks like our BGP network is up and running. Let's make sure that routes are passing through. Okay, we do have our static route here. All right. So we got all the neighborships formed. Now, the next thing that we want to do in our BGP configurations is to tell BGP which networks we want advertised. So starting here on Edge router 2, we're just going to say network 172.16.20.0 as a mask /24. And that's the only network that we need to advertise here. We also, going over to Edge router 1, Back to BGP configuration. We want to advertise 172.16.10.0. Also a /24 mask. Okay, done there. All right. ISP router 2 is going to have the most networks to advertise. First, we want to advertise network 10.0.5.0. /30. We want to advertise 10.0.10.0. And all right, done there. Don't really want to advertise anything on ISP router 1. Show up. See if we're learning anything. All right, we are learning a couple BGP networks here. Oh man. All right. Okay, we do have both of our interior networks being advertised and received. All right, before we get started with NAT, we are going to go up here to ISP router 1, right click, click capture, and then click G00. So we want to monitor packets coming in through the G00 interface utilizing Wireshark. All right, now that Wireshark's open, we're going to just go down here to our VPC, open it up, and say ping .8.8.8. All right, host unreachable. Okay, so that's kind of what we expected. We're going to close that, and we're going to check out our Wireshark terminal. See, okay, we did not see any of those packets come through. That's not right. So, all right, let's minimize that. Let's go to edge router 1 to see table show IP. Let's check the interfaces. There, show IP route. Okay, so here we are not getting our default route from BGP for some reason. All right, I'm gonna close this and I'm gonna check ISP router 2 real quick. Okay, so we are getting it here on ISP router 2. Now let's check edge router 2. Router 2 is getting it via 15.20 as well. Show IP. Okay, we're receiving it via BGP, but it's saying that the next hop is 15.10 instead of 15.20. And I would imagine that probably has something to do with us being on the same autonomous system. Well, this may not be the best and most correct way to fix it, but I do think I can do a workaround. So Alt T for right now. Let's say IP route. The next hop will be dot. Oops, not Oda. Try that. Okay. Now, exit, show. Okay, so now it's in our routing table. Okay. So let's close that for just a second and go back to our VPC. Try to ping data again. And it is receiving packets. Why is that? Wireshark. Oh, we advertise the networks, so of course, yeah, BGP knows about the 172.16.10.0 network. That was a mistake for displaying what I wanted to display with NAT. So here we're going to close that. We're going to go back here to Edge Router 1. I told you guys we're not trying to be perfect here. We're labbing together. So let's Alt T and router BGP 05 network. All right. Show. Neighbor. Dot. Okay, so we're not advertising any routes from Edge Router 1 to ISP Router 2. So we should be good there. Let's hop over to ISP Router 2 real quick to make sure those are cleared. It's not in the routing table any longer. Okay. So we still have that 172.16.20 network, but the 172.16.10 network is no longer in the routing table. So we're just going to hop over to Edge Router 2 and do the same thing real quick for the 16.20 network. And T. Work 172. Okay, that should fix that. Now, Third time's a charm. Let's see. All right, now that's what we expect to see. So we cannot reach Google's DNS server. And we can see here on Wireshark again. Let's look. And so we are trying. Okay, here they are. This is the new ones. These are the ones that I just sent. So we're trying to reach 8.8.8.8, but nobody knows where to send those ICMP echo replies back to. We can send the requests out, but we're not receiving any of the replies, and so they're timing out. And so, but to fix that, well, we saw one way to fix that. We can just advertise the BGP network, but for the purpose of this lab, we want to display NAT. And so first, we're going to configure static NAT and map we'll map VPC's IP address to the inside global address. So that's one of the things that kind of confused me. You may want to look up a chart if you are looking at NAT to see the difference between the inside local, inside global, outside global, outside local addresses. So it took me a little bit to get that straight in my head, but yeah, just check out a chart and you'll get it. But let's do conft. I'm going to say IP NAT inside source static, and we want to set it to VPC6's IP address, which I think is 172.16.10.2, I want to say. And it's going to ask for the inside global address, which is going to be our public IP, and that's going to be 10.0.5.2. I think that is it. So yeah, we don't want to figure anything else there. All right, so those should be mapped, and we're going to have to say interface G01 IP NAT inside and set it as our inside interface. Okay, and we're going to want to do interface G00 and say IP NAT outside. All right, that should fix that. And now again, let's close this, go back to VPC 6 and see what it tells us this time. Oh, there's no hosting for this. Okay, let's see. Figure it out real quick. Clear history. Maybe set. There it is. Set PC name VPC6. Okay, there we go. All right, so now again we're going to say ping 8.8.8.8, and there you go. Now we see that those replies are coming back, and we want to check out our Wireshark terminal. And as you can see, we are sending the ICMP echo requests and receiving them from the inside global address of 10.0.5.2. So we statically mapped VP6's IP address to the inside global address or the public IP address of 10.0.5.2. All right, and now let's minimize Wireshark. Let's close VPC6. Now VPC7 is on the same network as VPC6, and we're going to open VPC7 here, and we're just going to do the same thing. We'll say set PC name VPC. Okay. And here we're just going to say ping. Okay, so we're getting those timeouts on VPC7. And see, that's the problem with static NAT. You can only map one internal address to one global address. And that's what PAT or port address translation solves. Port address translations utilizes networking ports to give us the ability to map multiple interior IP addresses to one inside global address. And so that's what we're going to configure now. So let's just close VPC7 for now. We're going to go back to Edge Router 1. All right, we're going to say conf t, and we're going to say no IP NAT inside source static 172.16.10.2 to 10.0.5.2. Okay, so IP access list extended. We're just going to call it NAT list, and we're going to say permit all IP from 172.16.10.0 to any. Okay. So exit. And now that we have that access list, we can say IP NAT inside source. Now we can put our list, and we can say NAT list. And then we want to set, we can do it one of two ways. We can set it to an interface, or we can set it to a pool. And we're just going to say interface at this point, and then we're going to call it, we're going to say G00 interface. And here's the most important part for port address translation. You want to use that overload command, and that's going to set up that port address translation. And so exit. Now we should be able to exit here, go to VPC6, try to ping. And we're getting timeouts for something else to troubleshoot. Let's close VPC6. Let's open VPC7. Again, getting timeouts. Still getting everything for BGP. Okay, let's make sure I didn't misconfigure anything on NAT. Show run. So we have IP NAT inside source list, NAT list, interface G00 overload. G00 is the outbound interface. Let's say show IP. Okay, we do have one list, NAT list. Oh no, yes. That's the mistake I made. So on access list, I have a hard time remembering that for some reason. On access list, you use wildcard masks, not a typical subnet mask. So with that, I can't believe I forgot that. IP access list, I'm going to do extended access list, NAT list, and we're going to say no permit. And do show IP. Okay. So now that we got that cleaned up, we're going to just say permit all IP from 172.10.0. So that wildcard mask is the inverse of a subnet mask. So you just, instead of 255.255.255.0 to get a /24, you just do the inverse of that. It'd be 0.0.0.255. And we would say interface G00 overload. What did we forget? For interface. Oh, any. Oh, I'm trying to configure NAT. I'm sorry. It's late when I'm recording this, guys. My brain's not working all the way. Any. And we're good with that. We've already. Jeez. Got to get off of autopilot mode here for just a second and see about that. All right. Show run. Okay, now that should work. So let's close this. Go back to VPC 6. Try this again. And we are successful. All right, let's take a look at Wireshark. Scroll down. Okay, so yeah, we can see those ICMP requests and replies coming in via the inside global address. And now for the big test, let's go to VPC 7. Should be able to ping with it as well. And there you go. So we're able to ping with VPC 7 as well. Now, after all that messing up and troubleshooting and fixing, let's go over to Edge Router 2, and we're just going to go ahead and configure dynamic NAT, or not dynamic NAT. Dynamic NAT's a little different. Dynamic NAT, you configure a pool of inside addresses to a pool of outside addresses. So a pool of inside local addresses to a pool of inside global addresses. All right. So enable T access list. Extend it, call it NAT list as well. So permit IP from 17. Got that. Exit. That should fix that. And now we do interface G01. That's going to be inside. And interface G0. Come on. 0. Now outside. Okay. Let's close Edge Router 2. Go to VPC 8. Let's set VPC name. VPC 8. And ping. Okay, we're good on VPC 8. Close that. All right, we're good there too. So good deal. So I'm just going to wrap this up and go save all those configurations and export them for the configuration files and the GitHub. And so in this lab, we configured some loopback interfaces on the routers to establish some very resilient BGP neighbor adjacencies. We configured static routes to the loopback interfaces so that the routers would know how to reach them. We configured BGP on all the different routers. We configured static NAT on Edge Router 1 and saw how it worked with one device. We viewed those packets on Wireshark. We configured port address translation on our routers and tested them with our VPCs. And so, guys, I really hope you enjoyed this lab. If you got any value at all, I would love to hear from you. I'd love to see your comments down below. And if you would like to see more of these, be sure to like and subscribe. And so until next time, guys, I'll catch you on the next one.